Assalamualaikum everyone. My name is Nur Shakila binti Muhammad Shamsul Anwar with matric number CE2040039. I'm going to explain on how my coding works on and the function of the coding. This MATLAB code calculates the area enclosed between the two curves using double integration, symbolic integration with respect to y first and then x. So first of all, it is in MATLAB, which is sims. It declares about symbolic variable, which is x and y, allowing MATLAB to perform symbolic math like integration. These are two function curve, which is y underscore top is the upper boundary, and y underscore bottom is lower boundary. Third, in inner integral, which is I integrate with respect to y. In MATLAB, I use inner underscore integral. This calculation, the area between curve vertical from y bottom to y top, and fourth, I use outer integral, which is integrate with respect to x. Next, I use to simplify the result, which means simplifies the symbolic result if needed, but not always necessary, but make the output cleaner. Lastly, display the final result. In MATLAB, I use display, the area enclosed by the curve is, and I use display function. For the final output, after we run this coding and we save this coding, I used to get the result, which is 17/6, which this is the final result. And this code uses double integration to calculate the area between two curves over a given interval on the x-axis using symbolic mathematics in MATLAB.
Assalamualaikum. My name is Nuriza binti Hashim. My matrix number is 20492. So today I will be presenting about the second question. So I will be presenting the MATLAB solution for calculate the area enclosed by a specific region by using the double integration. So in our problem, we need to solve the integration over a region bounded by a certain limit of x and y instead of manually calculation integral. So we are using to MATLAB that allow us to automate this process for using in the symbolic and capabilities. So first is we need to defining the symbolic variable of x and y. Then we set up the integration limit for y from range -2 to 2 for x, which is bounded by negative y square root and y plus 4. And next, we are setting up for the double integral. So this step is to define the double integral in MATLAB int function that allows us to perform the integration first with respect to x and followed by y. And to get the clear result, we used to simplify, which refine the output and the final calculated area, then displayed by using the print result into 64/3 square unit. When we run the MATLAB, we actually get the following output in the corner window. So the area are enclosed by the region is 64/3 unit square. So in summary, MATLAB provides a structured, efficient way to solve the complex integration by using the symbolic computation, and this approach to minimize the manual errors and ensure the quick calculation. So that's all from me. Thank you. Assalamualaikum. My name is Nuriza binti Hashim. My matrix number is 20492. So today I will be presenting about the second question. So I will be presenting the MATLAB solution for calculate the area enclosed by a specific region by using the double integration. So in our problem, we need to solve the integration over a region bounded by a certain limit of x and y instead of manually calculation integral. So we are using to MATLAB that allow us to automate this process for using in the symbolic and capabilities. So first is we need to defining the symbolic variable of x and y. Then we set up the integration limit for y from range -2 to 2 for x, which is bounded by negative y square root and y plus 4. And next, we are setting up for the double integral. So this step is to define the double integral in MATLAB int function that allows us to perform the integration first with respect to x and followed by y. And to get the clear result, we used to simplify, which refine the output and the final calculated area, then displayed by using the print result into 64 over 3 square unit. When we run the MATLAB, we actually get the following output in the command window. So the area enclosed by the region is 64 over 3 unit square. So in summary, MATLAB provides a strong.
Hi, my name is Janice Febinti Nuraimi and my metric number is BE2030249. So today I'm going to introduce to you how to solve the problem using the MATLAB. Okay, at first we must open the MATLAB software. Okay, so as you can see, I show the symbol of plus, which means we need to add a new script. Okay, so first thing first that we need to do is to define the symbolic variable. Okay, what we define? Okay, we start by defining x as a symbolic variable. So as you can see, I write the coding. Okay, I write the coding. Okay, so why you use this coding is this allow MATLAB to perform algebra operation like integration symbolically. Okay, and then we need to define the function. Okay, we have two functions, so we need to define the top and the top and the bottom curve. Okay, so we have y bottom and y curve. Okay, so y bottom and y top and y bottom, we can get it from our manual calculation that we already do. Okay, so as you can see, I already write the top and the bottom. Okay, so the parabola is on top and the straight line is on the bottom in the interval -2 and 1. Okay. Okay, after we define the top and the bottom, okay, don't forget the semicolon. Okay, semicolon is very important in this MATLAB. If we didn't put the semicolon, the code not gonna be running. Okay, and after that we need to find the expression for the area. Okay, why we use this? Okay, we use this to subtract the lower function and the upper function to get the expression for the vertical distance between them. Okay, so we want to know the vertical distance between y top and y bottom. Okay, we need to subtract first lah. Okay, as you can see, I write it. Okay, after that, we need to integrate to find the area. Okay, why we integrate? Okay, we integrate this expression from -2 to 1 to find the total area enclosed between the curve. Okay, we already know the y expression integration. Okay, there are y top and y bottom. So for the x expression, we have -2 to -1. So because we need to double integration. Okay, so this is for the second integration. So for the y top and y bottom is for the first integration, and this x is for the second integration. And then we want to we already write the coding up first. So we need to simplify the result using MATLAB and to display the final answer. Okay, so as you can see, we use this coding, okay, to simplify the area. We want to get the area after the double integration. Okay, so after that, we need to display the sentence that's suitable for display the final. So what did I use? I used the area between the curve is. Okay, so after that, we're gonna get the output. Okay, so as you can see, I write the coding. Make sure don't forget the semicolon. Semicolon is very important. If not, your coding not gonna be running. Okay, so after we do this thing, make sure there are no wrong, to make sure the coding runs smoothly without any error. Okay, so as you can see, I have some trouble to write the coding. Okay, after we need to run the coding. Okay, when we run the coding, we need to save first. So what did I use? I used save the file by using question 2C. Okay, so as you can see, I run. Okay, I already run and you get the answer. Okay, so the answer is 9/2 units. So this is the correct answer from the manual calculation that we get. So that's all on how using the MATLAB. This simple MATLAB script show how symbolic make it easy to compute exact areas using integration. Okay, that's all from me. Thank you.
Hello everyone, my name is Ahmed Khalid Hamid. My matric number BE2030210. Today I will explain a simple MATLAB code. This code calculates the area between two curves, sin x and cosine x. We calculate this area from pi over 4 to pi over 2. The main idea is to find the difference between the two curves. We use absolute value and integrate it using MATLAB integral function. This gives us the total area between the two curves. Now I will explain the code steps. Step 1, clear the workspace. This remove all data and reset the MATLAB screen. Step 2, define limits for x. We are working from x equal pi over 4 to pi over 2. Step 3, define the functions. F1 is the sin x and F2 is cosine x. Step 4, calculate the area. We find the absolute difference and integrate it. Step 5, shows the result. This prints the area result on the screen. Finally, I will put the result is the number that shows the area. In short, this code uses math and MATLAB to find the area between two curves. Thank you for listening.